Welcome to this course on microprocessors and microcontrollers. So, this is a course where we will be discussing about the design and utilization of various microprocessors and microcontrollers. So, actually if you look into any computer system, the main computational element that we have there is the central processing unit or CPU. Along with that, we have got another very necessary components like the memory and the IO devices that we need to have in the system for interacting with the environment. So, for understanding this course on microprocessors and microcontrollers, so it will be required that we understand the basic digital logic designs like say logic gates, then in terms of computer architecture the basic number systems and all that. So, in first one or two lectures, so I will be covering those number systems and digital logic details, but of course, it will be better if you have got a full fledged introduction to those two courses. Now, these microprocessors, they are used very much in systems because they provide us the design of the central processing unit, and instead of having discrete components where we can have these components of the CPU taken separately as different chips and integrated onto a printed circuit board, it is better to put them into a silicon chip, so that this communication delay becomes the minimum. As you know that on chip delay is much less compared to the off chip delay. So, whenever we are pushing this PCB based design onto silicon based design, so the speed of the system improves. So, that was the basic objective with which these microprocessors got introduced, and there is a flow of this design of these microprocessors, starting with the very simple one and going towards more and more complex one. So, even today, so if you look into, so microprocessor architectures are evolving. So, since this is a basic course, so what we will do is we will start with the basic microprocessors, the very simple one which is 8085, and then we will slowly go to the higher microprocessors and microcontrollers. So, why these microcontrollers? Like most of the electronic gadgets that we have today, so they are based on a principle called embedded systems. In embedded systems, we have got the devices which will be doing some specific job, and that it will be doing it repetitively, and the architecture is optimized for that particular purpose. So, the total size of the device, like say cell phones, like the digital cameras and all these washing machine, or up to going up to say telephone exchange or the satellite launching system. So, everything they are examples of these embedded systems. Now, when you design this embedded system, so it is necessary that the overall size of the system be small, its power consumption be low, its footprint be less, so that we can say for example, a cell phone we can hold it in our hands like that. The battery backup should be battery life should be very high, so that it does not require much of charging, etc. So, microcontrollers, what they do, they actually take the microprocessor plus the additional things like the memory and the IO devices, timers, even the data converters like ADC and DAC into a single chip, and as a result you get a single chip computer. So, that is what a microcontroller is. So, in our course we will be looking into a number of microcontrollers as well, and you can understand that these are actually evolutions from microprocessors, where the these components were separate. The CPU was one chip and the memory IO devices, they were constituting separate chips, but here we have the one chip containing the whole thing. And again there are a large number of microcontrollers that have been reported in the literature. So, we will see into we will look into some of them, like say 8051, that is one of the basic microcontroller that will that is there, and it is quite popular because of its utility. And then we will be looking into a number of advanced microcontrollers, like ARM is another very advanced microcontroller, and here you have got the facility that it provides low power, and it is also programmable, in the sense that you can program that chip, and also you can program at the hardware level itself. Like if you think that I will not require a part of the hardware, so you can get rid of that hardware. So, in your chip design, so you may not take that part as a component of your chip, so that the overall chip size will be small. Apart from that, we have got other microcontrollers which are popular, like say PIC or PIC microcontroller and AVR microcontrollers, and these ranges, they have got they are family of microcontrollers, and they have got very simplest to very complex designs. So, both PIC and AVR, we have got these features, and they are providing some interesting facilities for which they may be very much useful. So, on our microprocessor side, so we will be looking into 8085, 8086, and on the microcontroller side, we will be looking into 8051, ARM, PIC and AVR microcontrollers. After that, we will be looking into a number of interfacing strategies, like a number of peripheral devices we need to connect to the microprocessor or microcontroller. So, how to do that? What are the standard interfaces that are available, and what is the standard procedure for connecting those devices to the system? So, that will be talked about, that will be covered in the interfacing portion. Finally, we will be taking a number of programming examples throughout the course. So, we will be taking a number of programming examples, so that we get a very strong hold on this programming part of these microprocessors and microcontrollers. So, with this, I welcome you to this course and hope you will find the course useful.